Is it a right triangle? Yeah or no? They want the sine of theta. Remember our buddy SOH CAH TOA? It is still, as much experience as I have, I write him on the top of the paper just so I don't confuse myself. This is too easy to get wrong. We must focus all of our attention around theta, and then let's do this. Which one's opposite, the 28, the 45, or the 53? Put a little OPP there. Yeah, you know me. Isn't this the adjacent? And this is the hypotenuse? They want two answers, is what we're going to put, exact and to the nearest thousandth. They don't want us to solve for theta. They want us to find the sine of theta, which is such an easy question that we get it wrong all the time. They just want it as a fraction. The sine is defined to be the opposite leg over the hypotenuse. Do you know how long the opposite leg is compared to theta? It's how long? 28 over the hypotenuse. How long is the hypotenuse? There it is. That is the sine of theta in this particular problem. The definition of sine is it is the ratio of the opposite guy over the hypotenuse. Can that fraction reduce? 28 over 53? We got to punch it in anyway because they want it to the nearest thousandth, right? So there it is. But how will I check to see if he reduces? Math, enter him. Did it reduce at all? Nope. So now approximate it to the nearest thousandth, approximately 0.5 to what? To 8? Y'all cool with that? Yes? No? Maybe? Cosine of theta. Theta hasn't moved. It's adjacent over hypotenuse. What is adjacent over hypotenuse going to be? 45 over 53, which is about, we got to punch that in, 45 divided by 53. Math, enter him real quick just to see if that reduces. Did it reduce? So 0.8 for what? 9, and the tangent, opposite over adjacent. (28 over 45). About 0.622, since we're rounding to the nearest hundredth, thousandth, if I can speak correctly. Y'all good with that? So simple, right? What is the tangent of theta? Well, it's opposite over adjacent, 28 over 45. Cool? Refer to triangle ABC at the right, find the sine of A, the cosine of B, the tangent of B. Do you see how they switch things around with us? Sometimes they're talking about angle A, sometimes they're talking about angle B. So putting the OPPs and the ADJs doesn't really help in this situation because that information is going to change because they focus around different angles. So let's find the sine of A. I'm going to put a theta in there. And let's see, sine is what over what? Opposite over hypotenuse. So what's opposite that theta right there? 6.5 over hypotenuse, which is, let's see if that reduces at all. 6.5 divided by 9.7, and then math, enter. Did it reduce? Yes. I mean, you just multiply everything by 10, but I'm not worried about that. Cool? It didn't come out to anything groovy like 3/4 or anything like that, so let's just put approximately what it was to the nearest thousandth, which is about 0.67 what? 0. Cosine of B. Got to focus your attention around a different angle now, so if you want to just put like an arc mark in there, if you want to erase your theta and put a different theta in there, that's all good. But now we got to focus around B. The cosine of B is adjacent over hypotenuse, right? Adjacent over hypotenuse, which is 6.5 over 9.7, which I hope you don't punch that back in because you get the same thing that you just had back. Tangent of B, find that for me. Focus your attention around B. And B, you need opposite over adjacent, 7.2 over 6.5, about 1.11. Don't go so fast that you get brain cramps, though. Take your time. If you need to throw the OPPs, ADJs, and HYPs in there, makes a big difference. Having our buddy's name up here, even easier. Do you have a right triangle? Yes or no? Do you have an angle and some sides? It's SOH CAH TOA time. So focus your attention on the angle provided to you that is not 90. You never use the 90. And let's figure out which trig function we want to use. 10 is what in relation to that 38? Opposite. And x is adjacent. Which trig function will we be using? The tangent, make sure you say their names right. It's sine, cosine, and tangent. The tangent of the angle measure, which is how much? Equals opposite over adjacent, 10 over x. Trig function, angle measure, ratios definition. Cool? Trig function, angle measure equals ratio. Rock and roll. Let's solve for x. Where's x? Upstairs or downstairs? We don't like that. Let's get rid of this divide by x by multiplying both sides by x. So x times the tangent of 38 equals 10. Then we divide both sides by the tangent of 38. Realize there are no 38s in this number at all. It is the tangent of 38 that we need to divide by. So x equals 10 over the tangent of 38. And now we punch that in our calculator. 10 divided by the tangent of 38 and close the parentheses because it automatically puts that parentheses. And they ask us to round how? Nearest tenth, so about 12.8. Do they give us a little unit to put it in? So just put about 12.8. Cool? Get an equation on 11, then check it with mine. It's a right triangle. They gave you an angle measure and a side length. If you have the right equation, solve that equation for x. Punch that in, round to the nearest tenth. Should it be more or less than 4? Well, you can use your reasoning skills. Should it be more or less than 4? It has to be more than 4 since this is the hypotenuse. 8.8, is that what you got approximately if this thing would ever work? 8.8. Sorry, video people. My pen is being a pain in the buns. 8.8. Cool. Next guy. What do they want you to find in this right triangle? Realize it is a right triangle. What do they want you to find? Side or angle? Angle. We need SOH CAH TOA to do it. So, which trig function would we use if this is the adjacent side to the angle we're looking for and 7 is the hypotenuse? Cosine of the angle measure, which is x, equals adjacent over hypotenuse. Correct? What we will do to find the x value when you don't know the angle measure is this is how it really works. You do this. Oh, goodness gracious. You take the cosine inverse of both sides, and what does an inverse and its function that is the inverse do to each other? They cancel each other out, right? So those are, you don't have to show this work. I'm just kind of showing you where it comes from now. The inverse cosine and the regular cosine multiply out to be 1. Is that right? That's what happens with inverses. So this is what we did back in the day. We just said make them switch places. The cosine inverse of 4/7 equals x. The 4/7 and the x just kind of do the old switcheroony, right? The inverse. To punch that in, those are right above your sine, cosine, and tangent buttons, right? It's the little -1, and you should know by now that that's read out loud as inverse, right? So 4/7, just type in 4 divided by 7. And how do they want you to round that? So x is about 55.2. Label, since that's an angle measure, it is in degrees. When you don't know the angle measure, that's the only time you use the inverse. Do that on 13 for me. You do not know the angle measure, you should be using an inverse. Pause the video, get that done. You are dealing with opposite and hypotenuse, so that's the sine function. You don't know the angle measure, so you need the inverse sine of 4/10. If you want to reduce it, reduce it. If you want to leave it 4/10, leave it 4/10, because you're going to get a decimal back anyway. So there you go. Pretty good refresher of trigonometry. Agree? Now let's get into, I wouldn't say tougher problems, but tougher for your memory. Read, discuss. What do we need? We have figured out that all the sides of this hexagon are 12. Could you tell me why you know that? Regular. That's what regular means. So you don't need to put them all in, but those two will be valuable to us. Cool. What else do we know? Heard some other good whisperings. The triangle that we would probably be focusing our attention on is this triangle, triangle ABC. Is everyone pretty comfortable with that? Right? Okay. Any kind of problems approach you as of now? You're all correct so far, but there's a problem. It's not a right triangle, meaning SOH-CAH TOA isn't that helpful to us at the moment. Can we get a right triangle? Let's discuss what we know about triangle ABC. It is isosceles. I'm going to notice that there's an isosceles triangle here. I'm going to drop this in. What did I just draw? It is the height of that triangle. And if a pilot told you that you are flying at a height of 30,000 feet, what's another word that he might say instead of height? The altitude of this isosceles triangle is very, 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 very special. First of all, an altitude goes from a vertex perpendicular to the opposite side. Perpendicular means at a 90. But the altitude of an isosceles triangle from the vertex does something to that base right there. It perpendicularly bisects it. So, okay, this is x and this is x, if you will, right? There's two equal pieces, right? Can we do Pythagorean theorem? No. Can we use trigonometry? It is true that we do now have right triangles involved. Little red right triangle. And the other one's congruent to it, right? They're exactly the same. Can we use trigonometry on that little red right triangle? Yet. What's missing? I need either this length right here, the altitude, or something else to do trigonometry. What was provided for us to do trigonometry in right triangles? An angle measure. Tell me, regular, if you just say all the sides are the same, that's called equilateral. Right? What else is true about regular polygons? All the angles are the same. So by God, wouldn't it be awesome to know what all the angles added up to in a hexagon that's convex? Wouldn't that be awesome? Man, if there was only a formula to figure out the sum of the angles in any convex polygon. Oh, cool. How about this? Number of sides minus 2 times number of sides minus 2 times 180. So this is a hexagon which has how many sides? 6 minus 2, which is 4 times 180. Punch that in. I would hope that you get 720 degrees total inside of that hexagon. Any convex hexagon has a total of 720 degrees. This is not your average convex hexagon. It's what? And you told me that meant that all the angles are the same, correct? Well, how many angles are there in that hexagon? I would hope that there'd be 6 sides, 6 angles. And if 720 degrees possible and it's split up 6 equal ways, what do you do to 720? Divide by 6. What'd you get? 120 degrees for each one of those angles. Formula, I hope you write this down. One angle of a regular polygon Find the measure of one angle of a regular polygon. You take the number of sides minus 2 times 180, then you take that result divided by the number of sides that you had. N minus 2 times 180 all over n. So didn't we get that to turn out to be 4 times 180 over 6, which equals 120 degrees? Cool. So every single one of these guys is 120 degrees. This is the altitude of an isosceles triangle. Isn't this entire angle right here 120 degrees? What does that altitude also do to that triangle? It is the symmetry line. So how much is that angle in here? 60 degrees and 60 degrees. If that picture gets too small for you, you can now sketch this for me. Just sketch your own off to the side. Don't you have 60 degrees, 60 degrees, and a 12 right here, and you're looking for x? Find x. Centimeters. So I did the sine of 60. Oh, God, it's like I stabbed myself in the back when I did that problem. I can't stand to do that problem that way. I just stabbed myself in the back. Because I'm a geometry teacher, and I just typed in the sine of 60. Did you hear that? That's what happens when you stab yourself in the back. I would never type in a trig function with the number 30 or 60 or 45. Why not? 30, 60, 90 right triangles and 45, 45, 90 right triangles are special. This is the long leg of a 30, 60, 90 right triangle. This is the 30. Isn't he the short leg right here? How long is that guy? 6. 6. Then how does this relate to it? Take the short leg times the square root of 2 or 3. Square root of 2 or 3. Square root of 3, because doesn't 30, 60, 90 start with a 3? This is 6 square roots of 3. This is 6 square roots of 3. Total, 12 square roots of 3. Just for fun, punch in 12 square roots of 3. I'll bet you get the same stinking thing. Isn't that amazing? But I asked the boss, what do you want on this? She said she didn't care. I care. You know, I want you to succeed on that ACT, and that would have taken way less time, if you know that, to realize it's 12 square roots of 3 and just punch that into calculator. If you see 30, 60, 90 or 45, 45, 90 right triangles, realize there's a shortcut. If you don't know that shortcut, come ask me and I will show you. Otherwise, this will work for you. But realize you're selling yourself short on that timed ACT that you have to take. You know what I mean? You're wasting time. Next, get that bad boy done. You and a pal work together. In a real life problem, we make basic assumptions that this, which is called what? The ground, and all trees or buildings or anything, we assume that they are what? Perpendicular, which that is not always the case, especially if there's a hill, you know, in that situation. So we have a right triangle situation. You all good with that dude right there being a right triangle? We knew that angle of elevation. You know why that's an angle of an elevation? Because which way did Juanita look? She looked up, right? Where did she look up from? That horizontal right there where she normally looks straight ahead. 62 degrees. If I find x right there using tangent, because that's opposite, and this is the adjacent side to it, right? I got 65.8 feet. Is that the answer to this question? Isn't this the right triangle that you just used right here? And you found x, which is this distance, correct? How tall is the building? So is x 70.8 feet? X is not 70.8 feet. X is 65.8 feet. But you must add 5, and the building is about 70.8 feet tall. Because realize this little nugget, new color, is not a part of x at all, right? That's that extra 5 feet that her eyes were off the ground. Should have been pretty comfy with that, especially when the picture was drawn for you. Eventually we'll have to draw our own picture. Yay for picture drawing. Last problem, the toughest of them all. Read to yourself. Let's see how confused we get. These have been the biggest struggle in this trig unit in Algebra 2, all because we can't draw the picture correctly. I want us to learn to draw the picture correctly. Are they giving you directions like on a map or on a compass? Yes or no? Start by drawing a compass rose, which is this. How about we want to draw this with this and solid segment and black. Do you know the 4 basic directions? What are they? North goes here. Never eat soggy Wheaties is what they taught me in elementary school. What did they teach you? Sour watermelon. I love sour watermelon. No. Never eat whatever, right? Never eat soggy Wheaties is what they told me. But north, east, south, west. Sound cool? Never eat sour watermelon, whatever. A ship. Here's where the ship started from. Cool? It sailed 59 kilometers on a bearing of 25 degrees. That means that when the ship just starts traveling with no arrows, it's going to make a 25-degree angle right in there. Cool? And here's a cool ship for you. There's our awesome ship right there. It sailed on a bearing of 25 degrees. How far did it sail? 59 kilometers. Everybody down with that? From where it started to where it currently is right now, 59 kilometers. Good deal? How far north and east of its original position is the ship? Well, all we need to do is do this. Connect. That. And what angle is formed right there, my friends? Right angle. Let's just make up variables for this. Let's call it x and y. You can call them whatever you really want to, but I'm using x and y. They want us to find both of them. Which variable, x or y, represents how far north this puppy moved? X. Isn't this going straight up north, right? So let's do this. North. Here's how far north he moved. We have a right triangle, don't we know an angle measure, and a side length. Trigonometry. So I'm looking for x. How is x related to the 25? Is he opposite, adjacent, or hypotenuse? Adjacent, and the side I have is 59, which is the hypotenuse, according to SOH CAH TOA. Which trig function are we using? Cosine of the angle measure equals adjacent over hypotenuse. Solve for x. Should it be more or less than 59? It's got to be less. That's the hypotenuse. 50 what? 3 to the nearest tenth? 0.5? Label? Kilometers. That was how far north it has traveled. Cool. Now east. Which variable are you looking for when you want to see east? Find y with trigonometry. Go for it. Still focusing your attention around the 25. Don't use this nasty number. You know, it's like you could, but use the 59. He's a nice, neat number. So that's opposite in hypotenuse. That's my sign. Da 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 da. 24 point what? Kilometers. You'll never guess what happened once they got there. You'll never guess. Arg. Go to ye next slide. You'll never guess what happened to this ship once they got there? Arg, go to ye. Next slide. Take a guess. What? They found the treasure? Not at all. They were attacked by, and the ship was taken over by pirates. As you can see right there, it became a pirate ship. Awesome. Thank you, SOH CAH TOA, for all your help today. Tangent.